Welcome to lesson number 4. We are looking at powers with whole number exponents. So in math, exponents are a way that we show repeated multiplication. So as an example, if I'm looking at this cube over here in this diagram, we would show the volume with repeated multiplication as 2 times 2 times 2. But we can also rewrite this as 2 cubed, right? This cubed, again, shows me how many times I'm multiplying my base. So exponents are also present in variables. So as an example where my side does not have a numerical value, instead is indicated by a variable. It's showing the same variable 3 times, and again we can express that as a cubed. So when we write powers, a power is the number written in an exponential form, so it consists of a base, which is denoted by a here, and an exponent n. So in one of these above examples, so 2 cubed, 2 is my base, 3 is my exponent. So in this class example number 1, I'm only going to do 2 of the questions here, but the base and the exponent, we want to state the base and the exponent in each of the following powers. So 4 is my base, and 5 is my exponent. Over here, -3 is my base, and 6 is my exponent. So you're also going to see numbers that multiply a variable. Those are referred to as coefficients. So in the expression 7p cubed, the coefficient is 7. Right, that's the number that comes before the variable and ends up multiplying the variable. So below we want to state the coefficient in each of the following. I'm only going to do the first 2 again, but my coefficient here is 8 in this first example, and this next example my coefficient is -3. Now note that written as repeated multiplication, 7p cubed, we would say is 7 times p times p times p, where my variable p is being raised to the 3rd power, so it's being multiplied 3 times. Whereas if I change that up to bracket 7p cubed, it then becomes 7p times 7p times 7p. And we'll be looking at these different examples as we go through the chapter, but I'll do all 4 examples in class example number 3. So we want to write each of the following as repeated multiplication. Now in this example, only the a has an exponent of 4. So this becomes 3 times a times a times a times a times b. So the a is being multiplied by a 4 times. Part B, only the b has the exponent. So we would have 3 times a times b times b times b times b. In part C here, a and b are being raised to the exponent. So this is going to become 3 times ab times ab times ab times ab. And lastly, my whole expression is going to be repeatedly multiplied by itself. 3ab times 3ab times 3ab times 3ab. Now, if I were to evaluate our powers here, so find out what the actual answer of these repeated multiplications are. 10 times 10 is 100, times 10 again is 1,000. So -6 times -6, we have a negative times a negative. Notice how my negative is inside the brackets. This is going to be positive 36. 3 times 3 times 3 times 3 gives us 81. Another way we can express that is 3 times 3 is 9 times 3 times 3, which is another 9. So 9 times 9 is 81. And then notice how now my negative sign is outside of my brackets, meaning this makes the whole expression negative, giving me a value of -36. One thing you might remember from last year was the zero exponent law. Now, with the zero exponent law, let's see what's what the trend is with our exponents when we raise them to the fourth, third, second, first, and then the 0 power. So 10 to the fourth gives us 10,000. 10 to the third, 1,000. Notice how we're losing 1 0 each time, which means that 10 to the 0 would be 1. 3 to 4 is 81. 3 to 3 is 27. 3 squared is 9. 3, 1. 3 to the 1 is 3. And 3 to the 0 is actually 1. And notice how we have the same trend occurring, dividing by 3 each time. Now, when we look at the exponent laws, we are going to look at the 0 exponent law in a little bit more detail. But anytime you have something raised to the 0 power, then the answer to that is 1. So anytime we have anything raised to the 0 power, our answer is going to be 1. So 6 to the 0 is 1. Negative 9 to the 0 is 1. Negative 9 to the 0 is 1. This is a little bit different. This is going to be equal to 2 because we have 2 times 6 squared to the 0, which is 1. 2 times 1, in this case, is 2. Now, I know I'm kind of flying through this video just so it doesn't take too long, but I encourage you again to go back, pause, and rewatch things if you're having difficulties, or if I'm simply moving too fast. Now, our exponent laws is when we use numerical whole number exponents and bases, and we've covered these before. So this is kind of a review. But if we were to complete this table using those laws, we have an example given on each side, and then we just got to complete the examples here. So our numerical base 8 cubed times 8 squared, then it shows our repeated multiplication and the process for simplifying. So with this variable base, a cubed times 8 squared, I'm going to write a cubed, or, oh sorry, I got to give the actual answer. So we count 1, 2, 3, 4, 5. There's 5 a's there. Another way we could express this is a cubed plus 2. All right, and so the general law here for the product law is if we have our base a, we need to add our powers. All right. When we have a cubed divided by a squared, notice how I have 8 divided by 8 times 8. Our answer is 1, or 8 to the power of 3 minus 2. Same thing over here, that becomes a to the power of 1, or a cubed minus 2. Now the general law for the quotient law with exponents is a to the power of m minus n, where our exponents are subtracted. Next we have our power of a product law. So what's happening is our exponent is being distributed into both the 8 and the 7. So this becomes 7 times 7 times 7, right? 8 times 7 times 8 times 7 times 8 times 7. Or we can simply write this as 8 cubed times 7 cubed. And the same thing's going to be happening on this side, b times b times b, or ab, or a cubed, b cubed. Now the general rule here is our exponent is distributed into our coefficients, both our coefficients. With the power of a quotient law, it's almost the exact same thing. We're multiplying our denominator and numerator 3 times, so our whole fraction is being multiplied. If we use variables to express that rule, it's going to look the exact same. But remember that exponent gets distributed to both the a and the b. So the general rule here is that a to the power of n, a divided by b to the power of n becomes a to the power of n divided by b to the power of n, where b, notice this restriction, cannot equal 0. And last, everybody's favorite, we have the power of a power law. And so the power of the power law, all this is telling us is that our powers are being multiplied. So 8 cubed to the power of 2 becomes 8 cubed times 8 cubed, or 8 times 8 times 8 times 8, times 8 times 8 times 8, which would be 6 eighths, or 2 times 3, or 3 times 2, however you want to look at it. Same thing on the bottom. If we replace our numerical values with actual numbers, a times a times a times a times a times a, which is a to the 6, or a cubed times 2. In general, our law here is a to the power of n times 2. Now I'm just going to do a couple of the exponent laws here. Here I have my product law, so 3 to the power of 4 times 3 squared. Notice how my bases are always the same when I'm doing these problems. So in order to combine exponents, bases need to be the same. So this becomes 3 to the power of 4 plus 2, which is equal to 3 to the power of 6. Over here, I have negative 2 to the power of 5 minus 3, or negative 2 squared. And here I have power of the product law, which is going to become 5 to 2 times 3, or 5 to the power of 6. These last problems, I'll do a few of them, but again, I'm not going to do all of them just for the sake of this video, not any too long. But here I have a to the power of 4 times a cubed. Now, we can just add these exponents. That's going to be a4 plus 3, or a to the power of 7. Well, I want to simplify this. I have x to the power of 6 times x, which is the same thing as saying x to the power of 6 plus 1, which would be x to the power of 7. X to the power of 8 divided, actually let's do this one. I have 7b to the 7 plus 0 plus 4, which would be b to the power of 11. And I'll do this one here. Y to the power of 10 divided by y squared. We would have y to the power of 10 minus 2, or y to the power of 8. Now I'm going to do the rest of these ones in class as a way to kind of recap what this video is about. But yeah, again, if I move too fast, go back and rewatch a few sections until it's starting to make sense. And if it's still not, then I'll help you out in class.